Hello everyone, I am Prakhyath, Assistant Professor, Department of Mechanical Engineering, AJIET Mangalore. Today I am going to discuss about Module 3 of Fluid Mechanics, this Class 2, continued portion of Fluid Dynamics. So let's go for problems. As I already discussed about Bernoulli's equation for real as well as ideal fluid in previous video, let us solve some problems related to Bernoulli's equation for real and ideal fluid. So first question, water is flowing through a pipe of 5 cm diameter under a pressure of 29.43 Newton per centimeter square. There is a gauge pressure and with mean velocity of 2 meter per second. Find the total head or total energy per unit weight of the water at a cross section which is 5 meter above the datum line. So this is our first question. So there is a pipe of 5 cm diameter, that is small letter D or capital letter D, you can take any symbol. So D equal to 5 cm under a pressure of 29.43 Newton per centimeter square. There is a pressure P equal to 29.43 Newton per centimeter square. There is a gauge pressure. And with a mean velocity of 2 meter per second. So velocity, mean velocity, that is represented by capital V, that is equal to 2 meter per second. Find the total head or total energy per unit weight of the water at a cross section which is 5 meter above the datum line. So there is a datum line, so which is 5 meter, the pipe is 5 meter above that datum line, that is Z equal to 5 meter. So now first we have to know what is total head. So total head, it is a summation of pressure head, velocity head and potential head. So that is P divided by rho g plus V1 square divided V square divided by 2g plus Z, that is the total head. So now we have to calculate total head using a formula pressure head plus kinetic head plus datum head. So pressure head, so that is a formula for pressure head, P by rho g. So this is a pressure head or pressure energy per unit weight. So P by rho g, so P value it is given in problem 29.43. Now 29.43 Newton per centimeter square, that is not the SI unit. SI unit of pressure is Pascal or Newton per meter square. Now we have to convert from Newton per centimeter square to Newton per meter square. So 1 centimeter is 10 to the power minus 2 meter. So 10 to the power minus 2 meter whole square. So that goes to numerator and becomes 10 to the power 4 plus 4 Newton per meter square. So pressure that is converted from 29.43 Newton per centimeter square to 29.43 into 10 to the power 4 Newton per meter square. This is a SI unit. So I have to convert from Newton per centimeter square to Newton per meter square just by multiplying 10 to the power 4. So pressure head P by rho g, P value is 29.43 into 10 to the power 4. So divided by rho, it is the water is flowing. So density of water, you have to remember 1000 into g is acceleration due to gravity 9.81. So 29.43 into 10 to the power 4 divided by 1000 into 9.81, that is equal to, so this is a pressure head. So head, you already studied about different types of head, friction head, then the head that causing the flow, various types of head in dimensional analysis. So that unit is meter. So I already used dimension L for head. So unit is meter. So 30 meter. By substituting values of pressure, density and acceleration due to gravity, we got value for pressure head as 30 meter. Since rho for water is 1000 kg per meter cube. So you have to remember density of water. So next is kinetic head. So kinetic head, that is related to kinetic energy or that is related to velocity. So V square by 2g. So V is given mean velocity in problem 2 meter per second. 2 square divided by 2 into 9.81. So that is equal to 0.204 meter. So there is a value of kinetic head. Again that unit is meter. Therefore total head, so total head is a summation of pressure head, kinetic head and datum head. Datum, it is already given in meter only. So that is 5 meter. The pipe is 5 meter above the datum. So it is given. So 30 plus 0.204 plus 5, that is equal to 35.204 meter. So there is a value of total head. So total head, you have to remember, it is a summation of pressure head, kinetic head and datum head or potential head. So answer is 35.204 meter. So there is a first problem. Going to second problem, a pipe through which water is flowing is having diameters 20 cm and 10 cm at the cross sections 1 and 2 respectively. The velocity of water at section 1 is given as 4 meter per second. Find the velocity head at sections 1 and 2 and also rate of discharge. Now what is velocity head? So velocity head means it is same as kinetic head. So kinetic head, it has velocity like v square divided by 2g. So velocity head is kinetic head only. So you are supposed to find here kinetic energy. So v square divided by 2g. For this, they told to calculate kinetic energy at section 1 and 2, that is v1 square divided by 2g and v2 square divided by 2g. So v1 is given in problem as 4 meter per second, and you can see the diagram. Diameter d1 20 centimeter, there's a higher value, so 20 centimeter, then 10 centimeter, so there's a small value, so d2 is small, d1 is 20, d2 is 10 centimeter. Just draw two lines, that is section 1 and section 2. So fluid is flowing, the water is flowing from section 1 to section 2. So diameter at section 1 is 20 centimeter and velocity it is given as v1 40 meter per second. So v1 for velocity at section 1, v2 for velocity at section 2, d2 again diameter at section 2. So now d1 equal to 20 centimeter, convert to SI unit. SI unit is meter, so 20 divided by 100, that is 0.2 meter. Then cross sectional area, as we all know, a cross sectional area, that is at section 1, a1 equal to pi by 4 d1 square. So d1 value is 0.2, so pi by 4 into 0.2 square, so that is equal to 0.0314 meter square. So that is the value of area 1. Next, d2 it is given as 10 centimeter, convert to meter, that is 0.1 meter. 10 divided by 100, that is meter, so 0.1 meter. Next, a2, similarly you calculate a2 cross sectional area, pi by 4 d2 square, so that is equal to pi by 4 into 0.1 square, as d2 value is 0.1, so that is equal to 0.000785 meter square. Now we know velocity at section 1, so we can calculate velocity head. So velocity head at section 1, that is equal to v1 square divided by 2g, so that is equal to 4 square divided by 2 into 9.81. So velocity head at section 1 is 0.815 meter. Next, now we don't know velocity at section 2, so we are supposed to find that velocity v2 before going for calculation of velocity head at section 2. So that can be obtained by using one relation, that is q equal to a1 v1 equal to a2 v2. So there is a relation, you have to remember, there is a relation for discharge. So a1 v1 equal to a2 v2. So now from that a1 is known, v1 is known, a2 is known, so you can calculate v2. So v2 equal to a1 v1 divided by a2. So a1 is 0.0314, v1 it is given in problem into 4, divided by a2 is 0.00785. So answer is 16 meter per second. There is a velocity at section 2. Now velocity head at section 2, that is equal to v2 square divided by 2g. So v2 value is 16 square divided by 2 into 9.81. So I got answer as 83.047 meter. So there is a velocity head at section 2. In addition to velocity head at section 1 and section 2, they have asked rate of discharge. That's what I told. Q equal to a1 v1 or a2 v2. Q equal to a1 v1 equal to a2 v2. So you can use either of any equation. I'll go with a1 v1, q equal to a1 v1, a1 is 0.0314, v1 it is given in problem into 4, so that is equal to 0.1256 meter cube per second. So here also don't get confused how to write unit for q, as I already told in dimensional analysis, there is a volumetric flow rate measured in meter cube per second. Otherwise you can calculate the you can determine the unit, like unit of area is meter square into velocity unit is meter per second. So meter square into meter, that becomes meter cube per second. So unit is meter cube per second, 0.1256 meter cube per second. There's a value of rate of discharge, this q. So there's a second problem. Now moving to third problem, water is flowing through a pipe having diameters 20 centimeter and 10 centimeter at sections 1 and 2 respectively. The rate of flow through pipe is 35 liter per second. The section 1 is 6 meter above datum and section 2 is 4 meter above datum. If the pressure at section 1 is 39.24 Newton per centimeter square, find the intensity of pressure at section 2. So we are supposed to find pressure at section 2, that is P2. Now water is flowing through a pipe having diameter 20 centimeter and 10 centimeter. That's a tapered pipe. So tapered pipe means you already studied about tapered pipe in mechanics of material mom. So one side diameter is like you will have a varying diameter. Either it is gradually increasing or gradually decreasing. So it is gradually decreasing here. At section 1 it is 20 centimeter and at section 2 it is 10 centimeter. So it is given the section 1 is 6 meter above datum. Initially you draw one datum. So you just mark the center line of that pipe. So center line of that pipe is some it is at a distance of 6 meter. Just keep the pipe in inclined position and draw the center line and mark 6 meter above the datum. Next, similarly the section 2 is 4 meter above datum. Again from the datum to the center line at section 2 you are going to get 4 meter. So there is a datum difference. Z1 equal to 6 meter, Z2 equal to 4 meter. Diameter 1 is 20 centimeter, diameter 2 equal to 10 centimeter. Then pressure at section 1 is given as 39.24 Newton per centimeter square. So there is a pressure P1. Now we are supposed to find P2 value. So here you have to draw the diagram. It is very easy to draw the diagram. Tapered pipe, one it is clearly mentioned. Section 1 is 20 centimeter, section 2 is 10 centimeter. Keep the pipe in inclined position. Then draw center line. From that center line to the datum line measure 6 meter at section 1 and from center line to datum at section 2 there is a 4 meter, that is Z2. So at section 1 D1 equal to 20 centimeter, convert to SI unit, that is equal to 0.2 meter. So get value of A1 cross sectional area. A1 equal to pi by 4 D1 square. So D1 is 0.2, pi into 0.2 square divided by 4. So that is equal to 0.0314 meter square. Now pressure P1 39.24 Newton per centimeter square. So Newton per centimeter square has to be converted to SI unit, Newton per meter square. So you can just remember, or you can get value of pressure in Newton per meter square by substituting in place of centimeter 10 to the power minus 2 meter square. Then it goes to numerator 10 to the power, it becomes 10 to the power 4. Otherwise you can just remember to convert Newton per centimeter square to Newton per meter square, you have to just multiply by 10 to the power 4. So 39.24 into 10 to the power 4 Newton per meter square. So Z1 there is a datum, there is a height difference from datum to center line of pipe at section 1, it is 6 meter. Then at section 2 D2 equal to 10 centimeter, so that is equal to 0.1 meter. So cross sectional area pi by 4 D2 square, that is equal to D2 is 0.1, so pi into 0.1 square divided by 4. So that is equal to 0.00785 meter square. There is a cross sectional area at section 2. Z2 it is given, so height from center line of the pipe to the datum at section 2, that is 4 meter. Now rate of flow, what is rate of flow? This term is very important, that is Q or volumetric flow rate. So that is equal to 35 liter per second. So how to convert liter per second to meter cube? So this factor you have to remember, liter to meter cube can be converted by multiplying 10 to the power minus 3. Just remember, this is very important, liter to meter cube. So that can be done by multiplying 10 to the power minus 3. 35 into 10 to the power minus 3 meter cube per second, or that is equal to 0.035 meter cube per second. So a very important conversion factor in this problem. So liter to meter cube, just multiply by 10 to the power minus 3. So 0.035 meter cube per second, that is Q value. Now rate of flow 35 liters, so 0.035 meter cube per second. So that is a Q value. So Q equal to, we know expression A1 V1 equal to A2 V2. So Q equal to 0.035, that is equal to A1 V1, that is equal to A2 V2. Now we can use one equation and we can find value of V1. So V1 equal to Q by A1, as Q is known and A1 is known. So V1 equal to Q value is 0.035, A value is A1 is 0.0314. So 0.035 divided by 0.0314, we get a value of V1 as 1.114 meter per second. Similarly, I can use Q equal to A2 V2 so that I can find value of V2. V2 equal to Q divided by A2. So V2 equal to 0.035, as Q value is 0.035 divided by 0.00785, that is the area A2. So velocity 4.456 meter per second. Now this is very important. We are supposed to find P2. So there is a in terms of Newton per meter square. So that can be obtained by applying Bernoulli's equation at section 1 and 2. We get Bernoulli's equation. So actually Bernoulli's equation is P by rho g plus V1 square divided by 2g plus z equal to constant. So there is a Bernoulli's equation. For section 1 and 2 it is P1 divided by rho g plus z1 plus V1 square divided by 2g, that is equal to P2 divided by rho g plus z2 plus V2 square divided by 2g. So applying Bernoulli's equation at section 1 and 2. So now we have values of P1, then z1, V1, V2 and z2. So we can get easily value of P2. So that can be done like this. So pressure P1 is 39.24 into 10 to the power 4 divided by rho, that is water. So 1000 into 9.81. Z1 is 6 plus V1 is 1.114. We got from expression Q equal to A1 V1. So 1.114 square divided by 2 into 9.81. G value is 9.81. There is acceleration due to gravity. That is equal to P2 divided by 1000 into 9.81 plus 4. So plus 4, that is Z2 is 4 plus 4.456 square divided by 2 into 9.81. V2 is 4.456. So upon simplification I get expression like this: P2 divided by 1000 into 9.81, that is equal to 41.051. Now P2 can be obtained by just cross multiplying 1000 into 9.81 to right hand side. So P2 equal to 402,710.31 Newton per meter square. So if you want answer, you can keep here only, otherwise you can get in Newton per meter centimeter square. As P1 is given in Newton per centimeter square, just divide the value, whatever what the value you are getting, that is in Newton per meter square, by 10 to the power 4. So you get P2 as 40.27 Newton per centimeter square. To convert from Newton per centimeter square to Newton per meter square, you multiply. So in order to get Newton per meter square to Newton per centimeter square, you have to just divide. So dividing by 10 to the power 4, you get value as 40.27 Newton per centimeter square. So that is the pressure at section 2. Next problem. A non-uniform part of a pipeline 5 meter long is laid at a slope of 2 in 5. Two pressure gauges are fitted at upper and lower ends, read 20 Newton per centimeter square and 12.5 Newton per centimeter square. If the diameters at the upper and lower ends are 15 centimeter and 10 centimeter respectively, determine quantity of water flowing per second. So quantity of water flowing per second, that is Q, that is a volumetric flow rate, meter cube per second. We are supposed to find Q here, quantity of water flowing per second. So a non-uniform part of pipeline, that means it is the tapered one. So uniform means diameter should be same throughout the cross section. So here it is non-uniform part of pipeline. Length is 5 meter. It is given 5 meter long. Is laid at a slope of 2 in 5. So slope they have given here 2 in 5. So you are supposed to find now the volumetric flow rate. So pressure, the two pressure gauges. What is the function of pressure gauge? It is used to measure pressure. So pressure gauges are fitted at upper and lower ends. Read upper end. Usually you can take upper end always section 1 unless they are going to mention. So upper end is section 1. So that is 20 Newton per centimeter square, and lower end it is 12.5 Newton per centimeter square. That is P1 is 20 Newton per centimeter square, P2 is 12.5 Newton per centimeter square. You can ask one question here, why to maintain one section above and two section below. So it is just like time's sake, you can just take one upper end, and lower end you can take 2 you can take reverse also, but most of the cases we are going to take 1 above and 2 below. So unless they are going to mention in problem. So if the diameters at upper and lower ends at 15 centimeter and 10 centimeter respectively. So upper end, that is related to section 1, D1 is 15 centimeter and lower end D2 equal to 10 centimeter. Again you can write slope 2 in 5 inside the bracket, inside that cross section, and length equal to 5 meter. So now the section 2 that is passing through datum. So Z2 is 0. Now how to get Z1? Slope is given. Slope means it is always vertical distance divided by horizontal. So by using tan theta concept, you can get the Z1 value. So Z1 value is how much? So here length is 5 meter. So 5 meter. Now you want vertical. So vertical 5 meter. Slope it is given, that is slope equal to delta y by delta x or y by x. So slope value is 1.1 in 2 in 5. So 2 by 5 that is equal to the vertical you don't know, delta y or y divided by x, that is okay, otherwise I'll explain about that thing later. Just time sake, you just remember slope 2 in 5, length equal to 5 meter. So now at section L equal to 5 meter, at section 1 D1 equal to 15 centimeter, so that is equal to 0.15 meter. Convert from centimeter to meter. Then P1 equal to 20 Newton per centimeter square, so 20 into 10 to the power 4 Newton per meter square. Just converting from Newton per centimeter square to Newton per meter square by multiplying 10 to the power 4. Similarly at section 2 D2 equal to 10 centimeter, that is equal to 0.1 meter. So P2 equal to 12.5 Newton per centimeter square. So convert to Newton per meter square. 12.5 into 10 to the power 4 Newton per meter square. Then A1 equal to pi by 4 D1 square, cross sectional area at section 1. So that is equal to pi into 0.15 square divided by 4. So that is equal to 0.01767 meter square. Similarly A2 equal to pi by 4 D2 square. So that is equal to pi into 0.1 square divided by 4. So that is equal to 0.00785 meter square. So those are the values of A1 and A2. Just you have to remember cross sectional formula, area formula, that is pi by 4 D square. Then let the datum is passing through center of the lower end, then Z2 equal to 0. So Z, you can see section 2 that is passing through the datum. You can see here. So Z2, the distance from center of the pipeline to the datum, that is 0 at section 2. Then you are supposed to find center distance from center of the pipe to datum at section 1. So that can be found like this. You can find that thing like this. You just see there value is a slope 2 in 5 means Z1 equal to, so Z2 is anyhow 0, so Z1 equal to 2 by 5 into L. You just multiply 2 by 5 into L. So here the length is given as 5, so 2 by 5 into length, so 2 by 5 into 5, so that is equal to 2 meters. So Z1 is 2 meters. So distance from center line of the pipe to the datum line is 2 meter. Otherwise you can use the concept slope equal to y divided by x. That can be also done. Otherwise you just remember Z1 equal to 2 by 5 into L. So there is a slope. Now A1 V1 equal to A2 V2, that is equal to rate of flow, that is equal to Q. Q equal to A1 V1, that is equal to A2 V2, that is for incompressible flow. Okay, so now V1 equal to A1 A2 V2 divided by A1. So now velocity, as velocity is not given, so V1 equal to A2 V2 divided by A1. V1 V2 values are not given, so I have to find that value. So that can be done like this. A2 is 0.00785, A1 is 0.01767, so 0.00785 divided by 0.01767 into V2. So I am expressing V1 as a function of V1 in terms of V2. So V1 equal to 0.444 V2. This is the relationship between V1 and V2. Now applying Bernoulli's equation at section 1 and 2, we get P1 divided by rho g plus Z1 plus V1 square divided by 2g, that is equal to P2 divided by rho g plus Z2 plus V2 square divided by 2g. So applying Bernoulli's equation at section 1 and section 2. So values are given. P1 is 20 into 10 to the power 4 divided by 1000 into 9.81 minus, so you can just substitute the values here. P1 value is given as 20 into 10 to the power 4 and Z1 is 2. P1 is 20 into 10 to the power 4 divided by 1000 into 9.81 plus Z1 is 2 plus V1 square, you keep V1 square as it is, V1 square divided by 2G or 2 into 9.81. So that is equal to P2 value, it is given in problem as 12.5 into 10 to the power 4 divided by 1000 into 9.81 plus Z2 is 0 plus V2 square. In place of V2, you can keep as it is V2 square divided by 2G, but in place of V1 you can substitute 0.444 V2 square. So 0.44 V2 whole square divided by 2 into 9.81. So upon rearrangement we can get expression like this: P1 minus P2 divided by rho G, or 20 into 10 to the power 4 divided by 1000 into 9.81 minus 12.5 into 10 to the power 4 divided by 1000 into 9.81 plus 2. So Z1 is 2, and that is equal to V2 square divided by 2 into 9.81 minus V1 square divided by 2 into 9.81. But V1 is 0.44 V2 whole square. So V2 square divided by 2 into 9.81 minus 0.444 V2 whole square divided by 2 into 9.81. So 20 minus 12.5, you can get the value as, you get value as 7.5 into 10 to the power 4. Denominator is common, so I can take LCM. 7.5 into 10 to the power 4 divided by 1000 into 9.81. Otherwise you can simplify each term and you can write the answer plus 2. So that is equal to taking V2 square common in right hand side equation, V2 square divided by 2 into 9.81 common. So in first term it is 1 is common, 1 minus remaining term is 0.444 square. So now simplifying left hand side, upon simplification of 7.5 into 10 to the power 4 divided by 1000 into 9.81 plus 2, I get value as 9.645. That is equal to V2 square divided by 2 into 9.81, 1 minus 0.444 square, that is 0.8028. So V2 equal to, just cross multiply and take the square root, 9.645 into 2 into 9.81 divided by 0.8028, take the square root. So V2 is 15.35 meter per second. So V2 value I got, so I can get V1 value using the equation V1 equal to 0.444 V2. So here it is not necessary, they didn't ask V1. So discharge they have asked here, Q equal to A1 V1, that is equal to A2 V2. So if you want to use A1 V1 expression, then you need to calculate V1 using V1 equal to 0.444 V2. So it is not necessary, so I'll go with second equation, Q equal to A2 V2. So Q equal to A2 V2 equal to A2 value is 0.00785, V2 is 15.35 into 15.35, so that is equal to 0.1205 meter cube per second. So in order to convert from meter cube per second, is same concept, liter to meter cube multiplying by 10 to the power minus 3. Now in order to convert from meter cube to meter cube per second to liter per second, you have to just multiply by 10 to the power 3 plus 3, or you have to just divide by 10 to the power minus 3. So anything is fine, otherwise you can keep in SI unit meter cube per second. So that is 0.1205 meter cube per second. So if you want to convert to liter per second, just divide by 10 to the power minus 3. So it becomes positive. 10 to the power 3, it goes to the numerator. So 120.5 liter per second. Next problem, a pipe of diameter 400 mm carries water at a velocity of 25 meter per second. The pressures at the points A and B are given as 29.43 Newton per centimeter square and 22.563 Newton per centimeter square respectively, while the datum head at A and B are 28 meter and 30 meter. Find the loss of head between A and B. So this problem is related to real fluid because there is a head loss. So as I already explained in theory portion, there's in previous video, because of the viscosity of the fluid, there's a friction. Because of the friction, there will be some energy loss. So that energy loss is called as head loss here. So you are supposed to find head loss. So here we are going to add that head loss to left hand side, that is for section 2. As at entry point there is no loss, when it moves gradually through the pipe at section 2, we are going to get that loss. So here just draw the diagram. Pipe of diameter 400 mm carries water, so at a velocity of 25 meter per second. So the pressures at point A and B are given as 29.43 and 22.563 Newton per centimeter square. So diameter D1 and D2 is nowhere it is given. So that means pipe is uniform. So diameter is uniform. So D1 equal to D2 equal to 400 mm, that is equal to 0.4 meter. Similarly velocity, velocity, only velocity, one velocity value is given. So V1 equal to V2 equal to 25 meter per second. So because pipe is uniform, so that means A1 equal to V1 equal to A2 V2. Areas are same, so you can cancel A1 equal to A2. So V1 equal to V2, that is equal to some V value, that is 25 meter per second. So at point B, PB is given as 22.563 Newton per centimeter square. So Newton per centimeter square to Newton per meter square, it can be done by multiplying 10 to the power 4. 22.563 into 10 to the power 4 Newton per meter square. ZB datum is given as, at B it is given as 30 meter. Datum had at A and B. So B it is 30 meter. So VB equal to V, that is 25 meter per second. Similarly, ZA is 28 meter and PA is 29.43. So you can replace P1 by PA, P2 one term by A term and B term by 2. So sorry, 1 by A and 2 by B. So it is because it is in problem, it is given as at points A and B. So it just replace. So PA by rho G plus ZA plus VA square divided by 2G, that is equal to PB divided by rho G plus ZB plus VB square divided by 2G. So this is a modification plus HL. There's a head loss. So PA is given as 29.43 into 10 to the power 4 divided by 1000 into 9.81. ZA datum had at A, that is 28. Plus 25 square divided by 2 into 9.81, thus VA value is 25, that is equal to 22.563 into 10 to the power 4 divided by 1000 into 9.81. P2 value is 22.563 into 10 to the power 4. ZB is 30 plus 25 square divided by 2 into 9.81. VB value also 25 plus HL. Now HL can be obtained by rearranging. So HL equal to 29.43 into 10 to the power 4 divided by 1000 into 9.81. Taking pressure heads together, minus 22.563 into 10 to the power 4 divided by 1000 into 9.81 plus 28 minus 30 plus 25 square divided by 2 into 9.81 minus 25 square divided by 2 into 9.81. So you can cancel velocity because velocity is same, so that becomes 0. Then remaining terms, pressure head and datum head or potential head, you can just simplify and get value of HL as HL equal to 5 meter. So there is a head loss, there is a 5 meter. So last problem, a conical tube of length 2 meter is fixed vertically with the smaller end upwards. The velocity of flow at the smaller end is 5 meter per second, while at the lower end is 2 meter per second. The pressure head at smaller end is 2.5 meter of liquid. So the loss of head in the tube is given by 0.35 V1 minus V2 whole square divided by 2G, where V1 is the velocity at smaller end and V2 is the velocity at lower end respectively. So determine pressure head at lower end. Flow takes place in downward direction. So here smaller end is upwards, so small cross section should be upwards, and pipe is vertical. You have to keep pipe vertical, tapered pipe with smaller end upwards and like a bigger end or larger end downwards. So you can see the diagram like that. So flow is taking place in the downward direction. This section 1 to section 2. You can see the arrow mark in the diagram. And length of the tube it is given as 2 meter, 2.0 meter, and velocity of flow at the smaller end. So V1 is 5 meter per second, and the lower end means it is a larger end, bigger end. So that is 2 meter per second. Thus V2 is 2 meter per second. Then the pressure head at the smaller end is 2.5 meter of liquid. So smaller end means that is related to 1. Pressure head it is, not pressure. P1 divided by rho G. The value is directly given, 2.5 meter of liquid. P1 divided by rho G, that is 2.5. Now you are supposed to find pressure head at the lower end, that is P2 divided by rho G was the value of P2 by rho G. But HL, instead of giving the value HL, they have given one correlation, that is HL is given by HL equal to 0.35 V1 minus V2 whole square divided by 2G. So using that expression we are supposed to find HL value. So let me start the solution. So V2 equal to 2 meter per second. Velocity is given as 2 meter per second as section 2, and at section 1 it is 5 meter per second. So loss of head, so HL equal to 0.35 into V1 minus V2 whole square divided by 2G. So that is equal to 0.35 into 5 minus 2 whole square divided by 2 into 9.81. So I can get value of HL as 0.16 meter. Now pressure head at larger end or section 2. So P2 divided by rho g is how much? Applying Bernoulli's equation at section 1 and section 2, we get P1 divided by rho g plus Z1 plus V1 square divided by 2g, that is equal to P2 divided by rho g plus Z2 plus V2 square divided by 2g plus HL. So that is for real fluid. Let the datum line passes through section 2. So it's similar to previous problem. Datum line passes through section 2. So Z2 value is 0. Z2 value is 0. Z1 is 2. So that is length of the tube. You can see that's height equal to the length of the tube. That's because the pipe is kept in vertical position. So upon substitution, P1 it is P1 by rho j, it is given as 2.5 meter of liquid plus Z1, that is equal to length of the tube, that is 2, plus velocity V1, that is given as 5 square divided by 2 into 9.1, that is equal to P2 divided by rho g. Don't substitute in place of rho g because they require, here we require pressure head at section 2. If you are going to get substitute rho as 1000 and g as 9.81, then you are going to end up with the P2 value, pressure. So then again you need to calculate P2 by rho g. So in order to avoid that, you just calculate P2 by rho g here only, without substituting for rho and g. And Z2 is 0, so plus 0 plus 2 square divided by 2 into 9.81. So the velocity at section 2 is 2 plus 0.16. There's a head loss. So upon rearrangement, 2.5 plus 2, that's 4.5. So taking 0.16 to other side, that becomes minus. So 4.5 minus 0.16 plus 5 square divided by 2 into 9.81 minus 2 square divided by 2 into 9.81, that is equal to P2 by rho g. So 5 square minus 5 square minus 2 square divided by 2 into 9.81. You can simplify, otherwise you can simplify 1 by 1. So I get value of P2 by rho g as 5.407 meter of liquid. So don't forget, unit is meter, it's not Newton per meter square because it is a head. So head unit is meter because HL also in head. So all values, I already used that expression in total head equal to pressure head plus datum head plus the velocity head or kinetic head. So unit is meter, don't forget that thing. So P2 by rho g is 5.407 meter of liquid. So this is a problem related to real and ideal fluid from Bernoulli's equation. This is chapter 1 of module 3. Okay, thank you.